going to do a brief overview on some testing on a 2003 Trailblazer that was towed in. The customer concern was it died while driving, so I'm going to kind of run through this briefly and fairly quickly. So first up was a file where it had dropout on the initial turn on it, but that there wasn't conclusive. Had to look at it a little more detail. So did this one here, a little more detail. We had dropout, but was on the wrong one here for seeing the control. So on to the next one, where second one, the dropout was here and it was on the control side. This one supplies power from the PCM. It has a constant ground on it. Whether this is normal or not, I don't know. I was fortunate enough to have another vehicle that was similar to take a look at, and that's in this file here. This was a 2004 Trailblazer, and it was in for some other work, but it had no known fault with the fuel system. So whether this is normal or not, I don't know, but two vehicles exhibited the same thing. Decided to focus testing elsewhere. The vehicle had 4 codes in it. The first up was a PO128. That one I was not able to get it returned, but thermostats are fairly common on Trailblazers. The other codes that it had in it were a PO171. The code set criteria on this particular code is if it's above 20% on the fuel trims, it will code, and we had here in this failure record total trim of 47%, which is quite a bit of correction, and it actually set 2 failure records for this specific code. Here's the other one. We'll zoom in on that, and again we're at 20 and 27, so again 47% total fuel trim correction. The other code that it had was a P1171, and that is a fuel system lean during acceleration. The code set criteria on this is that the O2 sensor is below 300 millivolts for over 3 seconds. This one here, you don't see a whole lot of correction on the fuel trim. Kind of hard to tell on the O2s, but the O2 is lean here. So moving on. So I suspected a fuel delivery issue on this. This here is a, I'll zoom in a little bit since the video quality is not great. This is a fuel pressure transducer with manage, and also the fuel control for the relay. Since it dropped out, I wanted to make sure that the PCM wasn't dropping out the control of the relay. So this is on an initial key up, and then we have our fuel pressure here. It's showing 7.2 and 8.8, and obviously it goes up here, but that's kind of a deal with the Vantage. The other connections I ran at the same time, you have battery voltage, the O2 sensor signal, since it was a indication of that it was lean for 3 seconds on it, it would set the code. And then also, since the ignition switches are an issue, I also tied in and made sure we didn't have an ignition switch or something of that sort dropping out. So this here was duplicated by after driving it for a while and then having it outside, sitting there and just running at basically 3/4 throttle, accelerating. The vehicle would sit there and sputter, and eventually could get it to die. So here we can see that it's changing as far as the engine speed on it, and here we see it's lean. It almost died here. It actually did die shortly after this, but I didn't record that on this image. Here's the Vantage during the same time. We do still have our control signal here, have our fuel pressure, but here it drops as far as where it comes off, and this is showing in the second image here. Take a look. We dropped from over 50 psi down to 18, so there's definitely a fuel delivery issue. Since it was had all the controls present on the other one, I decided to actually go ahead and add in fuel current to kind of take a look. And this is a fairly interesting capture here, where when the O2 is fairly normal here, we see its amperage is fairly decent, but then as the problem increases and the O2 goes low on it, we can see that the fuel pump current drops and drops and drops and drops. So let's take a zoom in on that a little bit there. At a much lower time base, it's really kind of hard to tell how much of the variance is on it. This is one instance where having the time cranked up really made a pretty good difference on it. So you can see there, and the even in this small area here, you can see the normal commutator bars here, but the amperage is going all over the place. It's a lot easier to see with it zoomed out all the way. Also in this image here, you can see where this one actually died all the way. We had our battery voltage here, and then the battery voltage dropped down as the vehicle actually died here. So let's go ahead and take a look again at the Vantage and see what the fuel pressure was. So again, we're nearly 50 psi before it dies, and then if we go to where it actually dies on it, with the fuel pressure dropping out like that, the customer was contacted, and we received authorization to pull the fuel tank down and put a pump in it. And this is what we saw coming out, was that definitely something not quite right there. There's contaminants on the sock of the fuel pump module. And taking a look inside the tank itself, there were also contaminants in the tank. Wasn't really quite sure what it was until after I was actually cleaning it out, and this is what I found. Whether it's a fabric marker or it's a kid's crayon, who knows, but it definitely created quite a bit of issue. So new fuel pump was installed, the tank was cleaned up, and ran much better with the fuel pump actually being able to go and draw in some fuel. Movies made by Samuel Jarvis. Thanks for watching.